Welcome, my dear students. We completed already in the previous topic standard hydrogen electrode or normal hydrogen electrode and electrochemical series we completed. Today we are going to discuss another topic, Nernst equation. Nernst equation. So already we just discussed in the galvanic cell that any electrode at any concentration gives us a cell, but Daniell cells are constructed only by using zinc metal reacts with copper ions, forms copper metal and zinc ions. Copper metal and zinc ions. Suppose, for example, the concentration of copper ions and zinc ions in the solution are at unit concentration. Means 1 molarity. Then we can calculate its cell potential as the 1.1 moles. If the concentrations are 1 molarity of copper ions and zinc ions, molarity concentration is, if suppose 1, then only we can calculate standard cell potential. Standard cell potential. Suppose if the concentration is not 1 molarity, in many cases it is not possible to maintain 1 molarity concentration. In many cases, in the practically, we are not able to maintain 1 molarity concentration. At that time, a scientist Nernst given cell potential E cell is equals to E naught cell minus RT by E electrode of the metal. Suppose here let us take a reaction of electrode M electrode. So taking n number of losing n number of electrons and convert to suppose for example n number of electrons takes and convert to a metal which is called a solid. Suppose a metal with a positive charge having that electrode takes n number of electrons and converts to metal solid. So for such type of electrode, we can write E of this electrode potential of this metal is m number of charges slash metal is equals to E naught standard electrode potential at 1 molarity concentration of this electrode. So this is already reference we have in the electrochemical series, right? These values we have in the electrochemical series. Now at any concentration, that electrode potential is called m power n plus, means number of charges are n plus slash m is equals to E naught. E naught means standard electrode potential of that electrode minus RT by NF. RT by NF. ln means nothing but similar to logarithms. Okay, so ln logarithmic calculations like this one also ln's. Okay, concentration of metal. Okay, because already we know that in the equilibrium reactions. So we studied in the equilibrium. So any concentration we will write in the form of product concentration divided by reactants concentration. Here also we considered like that. Okay, so like this here. So metal generally solid now here. So that's why its concentration is considered as the 1. So this is equation number 1. So from this we can write E mn plus slash m is equals to E naught m n plus slash m, means it is electrode representation. Okay, like zinc slash Zn plus 2 ions, how like this also it is a representation minus RT by NF ln. So metals concentration 1 no, so 1. Any substance solid substance molarity is always 1. Its concentration is always 1. So Mn plus ions concentration. Mn plus ions concentration. This is equation number 2. If suppose now if you apply this Nernst equation to this Daniell cell, Daniell cell, then we will get a equation. So similar to, for example, I am applying that equation here. So zinc reacts with copper ions. Suppose use copper metal and Zn+2. This is called Daniell cell. So if we apply this equation to this Daniell cell, what we will get? C here. Okay. Suppose E. If we want first zinc electrode, then we can write zinc ions concentration slash Zn. See here, the zinc converted to zinc ions. Oxidation, no? So anox, it is an anode. Okay. So here it is a reduction. Reduction is a cathode, no? So this is a cathode. Okay. This is for cathode. This equation is related to cathode, and this equation is related to anode. Okay. So first let us talk about anode. Electrode potential E is equals to E naught, standard electrode potential of the anode. So it will be given in the electrochemical series in the previous video. Okay. So Zn+2 slash Zn electrode, standard electrode potential. This is the potential value at unit concentration, means at 1 molarity concentration. Here this is the value of electrode potential. The concentration whatever it may be, less than 1 or greater than 1. Okay, understand? So minus, applying this equation I am, okay, RT by N. N means number of electrons lost or gained. Here in this equation, how many electrons are losing or gaining? Zinc C here, how many electrons losing? 2. Copper C here, how many electrons gaining? Here plus 2, it becoming 0 means how many electrons it gained? 2. Here how many electrons zinc losing? 2. So that N value here 2, number of electrons lost or gained. F is the Faraday, means the charge of the electron, Now ln 1 by, here concentration of the ions, so Zn ions, here we have Zn+2. Okay, this is the equation number 3. Okay, so suppose for example this is the electrode, this is the electrode potential of anode, and another one we have electrode potential of cathode. So Cu plus 2 ions are converting into Cu here. Okay, so that it is at any concentration. Similarly, we have to write standard electrode potential of copper, which is there in the table. You can see. Okay, so E naught is equals to E naught is copper ion slash copper is equals to E naught copper ion slash copper minus RT. Here also it gaining 2 electrons. So 2F ln 1 by, ln means similar to logs. 1 ln is equals to 2.303 log. Okay, so copper ions. Logarithms now this one. Ln speaking for. Okay, so we know that from our previous discussion. So E cell is equals to, or E naught cell is equals to E cathode minus E anode. E naught cathode minus E naught anode. Similarly, if you use this formula for at any concentration, This is the formula at standard concentrations of the cell. So here if we use the formula for at any concentrations of the electrode, so E cell is equals to E cathode minus E anode. E cathode minus E anode. Here just we lost the standard values because we are not able to maintaining the concentration of the electrolytes in the cell, so that's why we lost these standard values. That's why the formula is rewritten like this. Okay, so from this formula E cell is equals to cathode, which one? Here copper ion. So write down copper ion formula. So instead of this E cathode, we can substitute entirely this formula. So that is E naught Cu ions concentration slash Cu, okay, minus RT by 2F ln 1 by Cu plus 2 ions concentration minus, so anode which one? This one, E naught Zn plus 2 ions concentration minus RT by 2F ln 1 by Zn plus 2 ions concentration. So from this we can write E cell is equals to E naught Cu plus 2 ions concentration. Here I wrote already. E naught cell is equals to E naught anode minus E naught cathode minus E naught anode, right? So E naught Cu slash Cu, okay, minus, so this is E naught now, this minus multiply inside E naught Zn plus 2. I am rewriting the equation, that's it. I am rewriting the equation. So Zn, okay, minus. So if you take common RT by 2F ln, both are common now in this both. So in this and in this, we have common RT by 2F ln. Here also RT by 2F ln. So take common RT by 2F into ln into, so after ln, okay, otherwise you write this minus RT by 2F ln, okay, 1 by Zn plus 2 ions concentration, copper ions concentration. So minus into minus become plus, okay. So minus we remove, no, here common. So minus we will get again. So because here minus is there now, if we multiply with minus this one, plus. So here also if we multiply with this one, we will get plus. Okay, Zn plus 2 ions concentration. 1 by Zn plus 2 ions concentration. So 1 by Cu plus 2 ions concentration divided by 1 by Zn plus 2 ions concentration. Okay, this is the equation, and we know that this is a what? Copper ions, cathode. Okay, see here, copper ions, copper conversion is called cathode, similar to here, E naught. Okay, and this is anode, Zn plus 2 ions are anode. So see this, instead of these two, so minus formula E cathode minus E anode. So we will write, instead of this one, we write E naught cell. No? So E cell is equals to E naught cell minus RT by 2F. Log A minus log B formula. Log A by B. So ln A minus ln B formula. Ln A minus B formula. Ln A by B. So if we multiply this ln inside, ln A minus ln B will become. Okay. So it can be written as ln A by B. A by B means this is A and this is B. So 1 by Cu plus 2 ions concentration divided by 1 by Zn plus 2 ions concentration. If we write this one, so Zn will come up and so E naught cell is equals to RT by minus RT by 2F ln. So this Zn comes up so that it can be written as Zn plus 2 and copper plus 2. So this is the formula. Here R is called gas constant. Gas constant. Its value is 8.314. Okay, joule Kelvin universe mole universe. Okay. So real gas constant value 8.34. Suppose temperature is room temperature, then we can write 283 kelvins. 283 kelvins. And the Faraday value is always fixed. It will be nearly 15,000. Sorry, 9,500 approximately. 9,500 Faraday value. 9,500 coulombs. Faraday value will be 9,500. Okay. So coulombs per mole or mole universe. Coulombs per mole or mole universe. If we substitute these all values in the above and if we multiply, then E cell becomes is equals to E naught cell means standard electrode potential of that cell minus R value 8.31 and P value 283 kelvins, Faraday value 9,500. If we substitute like that, then ln value also 1 ln is equals to just now. So I told you 1 ln is equals to 2.303 log. 2.303 log. This 2.303 value and RTF value total entirely becomes 0.059 by 2 log. Now ln we should not write because ln value converted into log. 1 ln is equals to 2.303 log. Okay, so Zn ions concentration divided by copper ions concentration. So if we substitute all these terms in this equation, so R value here 8.31 and T value 283 kelvins, F value 9,500 and ln value 1 ln is equals to 2.303. So if we multiply all these four terms, okay, if we multiply all these four terms, then its value 0.059 by 2. So here 2 already present, so that's why that number of electrons 2 will be as it is remains. Okay, if the number of electrons loss or gain if 1, then 0.059 by 1 only. Okay, so like that this formula is derived. This is the very useful formula. Okay, this is called equation number 4, which is highly useful in solving problems of the electrochemistry. Okay, write down on all of you. So if you have any doubts, you can call me and you can ask me. So that's why, so that I can solve your doubts. I can clear your doubts. So Nernst equation we derived. This is a Nernst equation. E cell is equals to, for the Daniel cell we derived E naught cell, okay, minus 0.059 by 2 means here number of electrons for the Daniel cell, okay, or otherwise here we can write generally n number of electrons, okay. So log number of electrons loss or gain n value log, so Zn equals to ions concentration divided by, so here copper ions concentration. So in the Daniel cell we know that Daniel cell, I am writing once again, zinc reacts with copper sulfate solution, forms copper metal plus zinc ions. Here if you observe in the equation, so zinc ions are products divided by copper ions are reactants. So products concentration divided by reactants concentration. Products concentration divided by reactants concentration. Similarly, you can apply this equation, this similar equation to this one, another cell, which is called galvanic cell. Okay, so nickel reacts with silver ion or silver solution, so it forms nickel solution plus silver metal, forms nickel solution plus silver metal. If we apply this equation, the next equation for this cell, see the result what we will get. You try before my answer, you please try whether you will get which type of answer. Let us see, let us check. Okay, see, did you write answer? Please try, just write the products concentration divided by reactants concentration. E naught cell is equals to, E cell is equals to E naught cell of this nickel minus 0.059 by, for this number of electrons loss or gain. So here 1 electron is losing by gaining by Ag, here 2 electrons are gaining by nickel. Is it correct? So it is not balanced. So simply you can balance by keeping 2 here. So 2 silvers gained 2 electrons from the nickel. Nickel at a time losing 2 electrons into individual silver ions gaining 1 electrons, so that it forming silver metal. Okay, so here also number of electrons loss or gain n is equals to 2. N is equals to 2. So 0.059 I don't know, so you should write log value, not ln here, because 1 ln is equals to 2.303 log. So if you write 0.059 means it is completely already calculated value, 0.059 log. So what are the products here? Similarly we wrote products now. Product here is nickel ions. Products are divided by, here you have to observe carefully. Many of you maybe wrote mistake here. Silver ions. Products ions now. Silver ions. Raised to the power of the coefficient of the moles, or moles of the raised to the power. So you should raise the power of this concentration, means square. You have to write. Understand? Why? Because here we are taking 2 number of moles. That's why the concentration is also raised by the number of moles. Okay? Suppose any equation is similar to this given AA type reacted with BB forms C type, small C type reaction. This type of reaction we saw in the equilibrium lesson, right? For this K value we wrote reaction quotient or Q value. Reaction quotient Q is equals to products concentration raised to the power of number of moles. We wrote like this, right? Did you remember or forgot? A power A and B B power B. You wrote like this, right? So reaction quotient Q. Similarly, we can write this is also C for this cell. E cell is equals to E naught of the cell. And suppose for example, all the concentrations are maintained at one molarity, then its cell potential is universal. Here at different concentrations, minus RT by NF, because we don't know at what temperature we are doing, how many electrons we are losing, so that is this two value we don't know, so that we are writing completely RT by NF. So products concentration C power C, D power D by A power A and B power B. Okay. Okay. So here E cell is equals to E naught cell minus RT by NF. Sorry, I forgot log here. Okay, log C power C, D power D by A power A and B power B. Right? So log C power C, D power D, A power A, and B power B in the first year we wrote as the Q, reaction quotient. At any concentration, the rate of the reaction or the speed of the reaction is called reaction quotient. We know that. So here, instead of products concentration divided by reactants concentration, we can write Q, which is called reaction quotient. Reaction quotient. Okay, this is about reaction quotient in the Nernst equation, as well as the derived part for and application of the Nernst equation for some type of cells called galvanic cells. Okay. Especially if we take zinc copper, then we can call it as Daniel cell. Already we discussed. So zinc and copper if we take, then it is called Daniel cell. If we take only any other metal and any other electrolyte, then such type of cells are called galvanic cell or voltaic cell. This is the one type of voltaic cell. Like this we can construct a number of voltaic cell or number of galvanic cells. So if you have any doubts, you please contact me in the Zoom meeting, so that we can discuss. Okay. So if you don't have any doubts, so you please practice. I will give you some equations. So practice the equations and write the cell representation as well as the Nernst equation for both. Okay. Al plus 3, Al aluminium reacts with copper. Okay, forms copper metal and aluminium plus 3. So you should balance this one, and you have to write what? Nernst equation for this. You should balance yourself, and you should write Nernst equation like this. Just I wrote now. Okay, like this. You have to write. Okay, Nana? So easy. You try. Otherwise, I will give you answer. You try. You should try first. Okay. Then later we can see. So iron Fe plus 2. Iron reacts with copper Ce plus 2 forms Fe plus 2 plus copper. This is another cell. Okay. These two are your homework. These two are your homework. You should complete these two equations. Okay. And send it to me. Okay. Write the Nernst equation as well as the cell representation bar. Cell representation 1 mark. No. You know how to write cell representation by the slash and double slashes. Okay, that is 1 mark. And if you write the Nernst equation, that is also 1 mark. Very important. Okay, thank you. So stay home, stay safe. Okay, stay in the home and stay safe. Okay, Nana. Bye.